Simplify the square root of 125n. All right, this is the Nick Parrish math teacher go technique of simplifying square roots. You take your number, you make yourself a factor tree. All right, two numbers that multiply out to 125 are 5 and 25. Circle all the prime numbers. Keep going. 25 makes 5 and 5. Dunzo. Once you have your number ripped apart, you rewrite your square root using those numbers in order using the prime factorization. 5 times 5 times 5 times n. Any number that is an identical pair, you circle the pair and pull out 1. Okay, now we circled a pair of 5s, we're pulling out 1. We can't do it again because we don't have any more identical pairs. So that leaves us with a 5 on the outside, square root right here, 5 on the inside, n. And that's going to be our answer when all is said and done. See, not so bad. Simplify the square root of 200 m to the fourth n. Whenever you're asked to simplify a square root, radicals is what it's also called, and you have numbers and letters floating around on the inside, I like to use the Nick Parrish method of doing this, and that's by taking your number and making a nice factor tree. So any two numbers that multiply out to 200, so like 20 and 10, even though I said it in the wrong order, I wrote it out fine. 10 could still be ripped apart, that's 5. Circle the prime numbers, and 2, circle the prime numbers. 2 can be 5, circle the prime numbers, and 4. And 4 can be 2 and 2, prime. Now that we have that, rip apart the entire square root. So write out your prime factorization in order. 2 times 2 times 2. 2 times 2 times 2. Times 5 times 5. There's 4 m's, so 1, 2, 3, 4. And there's 1 n. So what I do now that I have everything ripped apart is you circle all pairs of identical objects and bring out one of each. Circle one pair of 2s, bring out 1. There's no more 2s that I can bring out, but I can circle a pair of 5s, bring out 1. Circle a pair of m's, bring out 1. Circle a pair of m's, bring out 1. No more m's, there's only 1 n, can't bring anything else out. So what I can bring out is I have a 2 times a 5 times an m times an m. What I have left over on the inside is 2 times n. On the outside, on the inside, multiply as much as you can. 2 times 5 is 10. M times m is m squared. On the inside, 2 times n is 2n. And there you have it. And we're done. That's it. So factor tree, rip stuff apart, pull stuff out, simplify, donezo. Simplify 7 times the square root of 96m cubed. In order to simplify a square root, the way I handle this is I like to make a factor tree and find the prime factorization of every number living inside the square root. So think of two numbers that multiply out to 96, like 3 and 32. Circle all the prime numbers. 32 is 8 and 4. Okay, each of these you can keep going. 8 is 4 and 2, circle a 2. 4 is 2 and 2, circle both 2's. Over here, 4 is 2 and 2, circle both 2's. Now keep that 7 out there. Okay, I'm going to have to deal with that in a little bit. But let's write out our prime factorization in order. 2 times 2 times 2 times 2 times 2, so that's 5 of them. 1, 2, 3, 4, 5, times 3. And then I'm going to rip apart my m's as well. Times m times m times m. Inside the square root, circle every identical pair and bring out one of them. So circle a pair of 2's, bring out 1. Circle a pair of 2's, bring out 1. Can't do anything there, can't do anything there. Circle a pair of m's, bring out 1. So I already have a 7 out here. I'm going to multiply to it 2, another 2, and an m. On the inside, I have a 2 times a 3 times an m left over. Now my last step is to clean all of this up. 2 times 2 is 4, times 7 is 28, so 28. M is on the outside. Square root. 2 times 3 is 6, and m is on the inside. And that's it. Not bad. Simplify negative 3 times the square root of 24 times a to the fourth times b squared times c to the third. Whenever I see a square root, I like to break it down into the smallest parts as possible by making a factor tree for the number. So like 24 is 2 and 12. Circle the 2. 12 is 3 and 4. Circle the 3. 4 is 2 and 2. Circle the 2. Now let's rewrite all this stuff out, leaving that negative 3 already out there. We're going to leave it out there. Don't need to mess with it. Putting this in order is going to be 2 times 2 times 2 times 3. So let's do that. Now this part seems redundant and maybe seems like a bit too much, but I'm going to do it anyway. I'm going to write out all my letters. A times A times A times A times B times B times C times C times C. Not necessary, but I like doing it. You know, my video, I do what I want. Now take every number inside the square root. Circle a pair and bring out one of them. Okay? 2 doesn't have another identical pair. 3 doesn't either. But A, circle a pair, bring out one of them. Another group of A's, circle a pair, bring out one of them. A group of B's, circle a pair, bring out one of them. A group of C's, circle a pair, bring out one of them. Negative 3 is still lingering on the outside. Times 2 times A times another A times B times C. And what we have left over inside the square root is going to be 2 times 3 times C. Okay, although I did a pretty bad job circling that group of C's, so let me scooch that over so it looks a little bit better. Look at that. All right, so let's kind of combine everything we can. Negative 3 times 2 is negative 6. A times A is A squared, B, C. And then inside the square root, we have 2 times 3, which is positive 6, C. And that's going to be our guy with that really long-looking square root, but I'm keeping it because I love it. Simplify negative 10 square root of 7 plus 12 square root of 7. Well, if you see a square root and the same exact square root and you're adding or subtracting, you're essentially combining like terms. So negative 10 root 7s plus 12 root 7s is going to be negative 10 plus 12, which is 2, and root 7 comes along for the ride. So it's just like combining like terms if they're the same exact root. Simplify negative 2 root 3 plus 3 root 27. Well, if you're looking at this and saying, well, these are different roots, I can't do anything, you're correct for now, until you realize that you can simplify the square root of 27. So let's go over here and say, oh, wait a minute, 27 is 3 times 9, circle U, and 9 is 3 times 3, circle U. So if I wanted to, I can turn 3 times the square root of 27 into 3 times the square root of 3 times 3 times 3, right? You simplify this the way you normally would, circle a pair of identical numbers inside but bring one of them out, leave that lonely 3 in there. So the 3 that already lives on the outside times the 3 that we're bringing out times the square root of 3 becomes 9 root 3. Now, we notice, oh, that's the same thing. So let's bring that down. We have negative 2 root 3 plus 9 root 3. Negative 2 root 3 plus 9 root 3 is going to be combining like terms. Negative 2 plus 9 is 7, and root 3 comes along for the ride. And so when all is said and done, we get 7 root 3. Simplify negative 3 times the square root of 18 plus 3 times the square root of 8 minus square root of 24. Now what we need to do is we need to change all of these square roots into something that can be simplified and see if any of the square roots match up. So let's take 18. Let's do this one at a time. 18 is 3 times 6, so circle the 3, and 6 is 3 times 2. So negative 3 square root of 18 can become negative 3 times 2 times 3 times 3, like that. Circle a pair of identical numbers and bring one of them out. So negative 3 times 3 square root of 2. Negative 3 times 3 is 9, and 9 times the square root of 2 is 9 times the square root of 2. So you are taken care of. Now let's deal with the square root of 8. So let's go over here. Square root of 8 is 2 times 2 times 2. So give me a second to write all of that out. So this is plus 3 square root of 2 times 2 times 2. Circle a pair of 2's, bring one of them out. So you have 3 times one of those 2's, leave a square root of 2 behind, and that becomes 6 root 2. So these guys will be able to combine. But I don't know about that 24. Let's go over and deal with that 24 over there. 24 can be, what, 8 and 3? So let's circle the 3. 8 can be 4 and 2, so let's circle the 2. And 4 can be 2 and 2. So this becomes minus 2 times 2 times 2 times 3. Circle a pair of identical 2's and bring one of them out. There's no more 2's and there's no more 3's, so you are left with minus 2 square root of 2 times 3, which is minus 2 root 6. Now the purple guy will not combine with these two guys, but these two guys will combine. So 9 root 2's plus 6 root 2's is 15 root 2's. You will not combine with them because you're a different square root, so minus 2 root 6. But at the very least we simplified it, so that's good. But yeah, if you can't combine roots, you can't combine roots. But in this case, we could combine these guys. So we did most of the job. We did all of the job, but, it wasn't perfect. It was just nice. Simplify the square root of 5 times negative 4 times the square root of 20. Whenever you're multiplying numbers and square roots, you multiply the like terms together. So that negative 4 just kind of lingers. However, if I were to combine these two and multiply these two, let's just write that out separately. Positive square root of 5 times the square root of 20. Okay? So when you multiply square roots, you multiply inside the roots. So you get the square root of 5 times 20, which is 100. Negative 4 times that is negative 4 times that. And you should be able to look at this and say, well, wait a minute. I know that the square root of 100 is 10. So negative 4 that was lingering out here times 10 is going to be negative 40. And that's going to be our guy. Simplify negative 4 times the square root of 28x times the square root of 7x cubed. Whenever you're multiplying coefficients and square roots, you treat them separate. Like negative 4, you're nothing like it. Everything else is inside the square root. Pull it off to the side. Now, when you have square roots and you multiply square roots together, you have one big square root and multiply everything inside. So 28 times 7 is 196. X times x to the third, treat that as an invisible 1, add the exponents, x to the fourth. Now this is lovely because both of the objects inside the square roots are perfect squares. So negative 4 lives out there. The square root of 196 is 14. The square root of x to the fourth is x squared. So when all is said and done, this becomes negative 4 times 14, which is negative 56. X squared comes along for the ride. That's going to be our answer. Simplify this FOIL problem involving square roots. Well, this is a FOIL problem because it's a binomial times a binomial. It just looks weird with all the square roots and stuff. No matter, we can do it. FOIL says you do the first guys first. So 5 times negative 2 is negative 10. The O part in FOIL says multiply the outer parts, so 5 times positive square root of 5 is positive 5 root 5. They don't combine because one is not a square root, but the other one is. Similarly, but different, you've got negative 4 times negative 2, which is positive 8, and that square root of 5 is just kind of lingering. So negative 4 root 5 times negative 2 is positive 8 root 5. This is where the game changes slightly, okay? Negative 4 root 5 times root 5 is going to be negative 4 because negative 4 multiplies to an invisible 1. The square root of 5 times the square root of 5 means you multiply inside the square root to get that square root of 25, which means, looking at all of this and kind of doing two things at the same time, right now nothing happens to negative 10. However, 5 root 5 plus 8 root 5s are like terms. So 5 root 5s plus 8 root 5s is 13 root 5s. Not 13 root 10s, 13 root 5s. I've seen a lot of people think that you should add inside. Nope, you're just saying, I have 5 of them, and I have 8 of them, now I have 13 of them. Now what happens here is the square root of 25 is a perfect square. So square root of 25 is just 5. So turn the square root of 25 into 5, and then you realize, oh, negative 4 times 5 is negative 20, so let's drop down to negative 10. Let's drop down to 13 root 5. These guys don't combine, but you know what? These guys do. And negative 10 minus 20 is negative 30 plus 13 root 5. These guys will not combine because one has a square root and the other one doesn't. So that's how you do that FOIL problem. Fun, fun. Simplify 4 over the square root of 5. This process is going to be called rationalizing the denominator. There's a stupid rule in math that says you're not allowed to have square roots in the denominator. It's a stupid rule because it's stupid and it's really not necessary, but you still have to learn how to do it anyway. Now, how do I get rid of a square root? Well, normally you would square it, but I can't just square the top and the bottom. That's against the rules. What I can do, though, is if all I have in the denominator is the square root of a number, I can multiply the top and the bottom by that same exact thing. Now, what that does to the top is 4 times the square root of 5 is still 4 times the square root of 5. I don't care what the numerator looks like. What happens in the denominator is the square root of 5 times the square root of 5 has me multiplying inside the square roots and leaving me with the square root of 25. Why is that good news? Because the square root of 25 is 5. And now I don't have a square root in the denominator anymore. So rationalizing the denominator is the process where if I have just a square root in the denominator, multiply the top and the bottom by that exact same thing, they will eventually, the square roots essentially cancel each other out because what you're doing is you're squaring this by multiplying it to itself and you're left with no more square root in the denominator. Isn't that fun? 3 over 4 plus 4 root 5 is against the law. Why? Because there's a square root in the denominator of a fraction. This process is called rationalizing the denominator. You're not allowed to have a denominator in the square root of a fraction. Now, in a previous video, I had just a square root in the denominator. Now I have a binomial. So what do I do if I have a binomial and a denominator and I need to get rid of a square root? Well, you multiply the top and the bottom by its conjugate. Now, a conjugate is literally the same exact thing, but flip the sign in the middle. So I'm going to multiply the numerator and the denominator by 4 minus 4 root 5. Okay, now let me write that out because it's going to be a little unpleasant. 3 times 4 minus 4 root 5 all over parentheses, because you know this is a parentheses, it's in one group, 4 plus 4 root 5 times the quantity 4 minus 4 root 5. Now, why is the conjugate important? What's going to happen? Magic is going to happen. You'll see. But let's worry about the numerator first. This is just distributive property. 3 times 4 is 12. And 3 times negative 4 is negative 12. Square root of 5 comes along for the ride. Now, what makes the bottom magical is when you multiply binomials, which means two objects in a parentheses where one is a positive sign and one is the minus sign. This is called a difference of squares. The two inside parts will always cancel out. Yes, this is a FOIL problem, but watch what happens. 4 times 4 is 16, no big deal. 4 times negative 4 is negative 16, square root of 5 comes along for the ride. 4 times 4 is 16, square root of 5 comes along for the ride. See what happens in the middle? And then 4 times negative 4 is negative 16. Square root of 5 times square root of 5 is square root of 25. I'll clean that up in a little bit. Now, the reason why this is good is, again, if you're looking at this and saying, I thought we were supposed to get rid of the square roots on the bottom. Give me a minute. Be patient. Nothing happens in the numerator. Nothing at all. Okay? 16 is still 16. But negative 16 root 5 plus 16 root 5 cancel each other out. That's the purpose of difference of squares. And if you're like, but you still have a square root here. 16 times the square root of 25 is the square root of 25 is 5. That's right. So you are left with 12 minus 12 root 5 over 16 minus 80, which is 12 minus 12 root 5 over negative, what is that, 64? Now, technically, I can do more with this, but I'm not going to worry about it. Right now, my focus is just cleaning this up, making this look pretty. Okay, so if your teacher is like, you're good, stop the video right now, you're good. If your teacher is going to make you simplify this, then keep watching. Okay, now, we are technically not done yet. Okay, technically not done yet. If we need to simplify this further, you might notice that both of these have, well, first off, you have a 12 and a 12 and a 64. Those all have 4s in common. I'm trying to think in my head. Yep, 4s in common, and that should do it. So what I can do is if I were to keep going, you can factor a 4 out of the numerator, which would make it look like this. You can factor a 4 out of the denominator, so that would be times negative 16. The 4 over 4 cancel each other out, and you're left with a final answer of 3 minus 3 root 5 over negative 16. So that's the correct answer technically. I think most Algebra 1 teachers would be okay with that, but you know, we did both. So there you have it. You're welcome. Find the distance between these pair of points. You have 3, negative 5, and negative 3, 0. Well, that requires the distance formula. Let's write it out. The distance formula is d equals huge square root of x sub 2 minus x sub 1, close it, square it, plus y sub 2 minus y sub 1, close it, square it. Now, what's x sub 2, what's y sub 1, and blah, 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 blah. Pick any of your points and call it x sub 1, y sub 1. Pick any of your points and call it x sub 2, y sub 2. Then we just kind of plug stuff in. Okay, so the distance is going to equal the big square root of x sub 2, which I labeled negative 3, minus x sub 1, which I labeled regular 3, squared, plus y sub 2, which I labeled 0, minus y sub 1, which I labeled negative 5, so double negative, I'll clean that up in a minute. And now it's just a matter of gross Pythagorean theorem looking stuff. Okay, negative 3 minus 3 is negative 6 squared. Double negative becomes a positive, so you become plus 5 squared. That's going to equal negative 6 times itself is 36, plus 5 times itself is 25, and when you add those guys up together, you get the square root of 61. Now, since this chapter focuses on dealing with square roots, or since I guess this unit focuses on square roots, I would look at this and see if there's anything you can do to change it, and the answer is no. Now, anybody can run to a calculator and try to find out that the square root of 61 is going to be like 7 point something, but I'm not worried about that. I'm going to think, all right, well, can I make a factor tree out of 61? No, 61 doesn't turn into anything, so I'm going to leave it like that because this is the square root section. So we're going to leave it like that. So that's my answer. Find the distance between each pair of points. Well, that requires a little guy called the distance formula. D equals big square root of x sub 2 minus x sub 1, close it, square it, plus y sub 2 minus y sub 1, close it, square it. Now, we take our points and we take any point and label it x sub 1, y sub 1. We take any point and label it x sub 2, y sub 2, and then we plug stuff in and see what happens. Okay, so d equals big square root of x sub 2, which I labeled negative 6, minus x sub 1, which I labeled negative 2, so double negative, we'll deal with that in a minute, plus y sub 2, which I labeled negative 8, minus y sub 1, which I labeled 2, close it, square it. Okay, so let's simplify that what we can. Double negative becomes a positive, so negative 6 plus 2 is negative 4 is squared, plus negative 6 minus 2 is going, I'm sorry, negative 8 minus 2 is going to be negative 10 squared. Simplify that a little bit. 16 plus 100. Negative 4 times itself is 16. Negative 10 times itself is 100. You become the square root of 116. Now, this unit focuses on simplifying square roots. Anybody could run to a calculator and type out the square root of 116, get 10 point blah, 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 blah. I'm not interested in that. Let's go over here and see if we can make a factor tree out of 116. Okay, so if I rip a 2 out of there, I am left with 58. I can rip a 2 out of there, and that leaves me with, what is that, 29? Yeah. So that's going to be that. I can't do anything with 29. So what that means is I can turn the square root of 116 into 2 times 2 times 29. When you're simplifying square roots, you circle a pair of identical factors inside the square root and pull out one of them. So bring out a 2, leave the 29, and the answer to this guy is going to be 2 root 29, which is roughly 10 point something. I'm not going to worry about 10 point what, because anybody could use a calculator. I want to do it this way. Just like the Backstreet Boys say, that they want it that way. Well, I want it this way. Remember them? Backstreet Boys? Like and subscribe, please. Find the midpoint between each pair of points. Well, mid is average. Mid also does mean average, according to Gen Z slang. But anyway, the midpoint formula is you're going to have a point, and the x value of the point is going to be the average of the x values. So x sub 1 plus x sub 2 divided by 2. And the y value is going to be the average of the y values. Y sub 1 plus y sub 2 divided by 2. So let's go to our point. Let's label them x sub 1, y sub 1, x sub 2, y sub 2, and plug stuff in. My midpoint is going to be x sub 1, which I labeled 2, plus x sub 2, which I labeled negative 9. So I know that looks sloppy, but it's not the end of the world. We'll take all of that, divide that by 2. Y sub 1 is negative 11, plus y sub 2, which I called 0, all over 2. Okay, so let's clean this point up and make it look a little bit prettier. 2 plus negative 9 is negative 7, so negative 7 all over 2. And negative 11 plus 0 is negative 11 all over 2. So maybe to look this a little bit better, let's whip out the negatives and make this negative 7 over 2, negative 11 over 2. 7 and 11, how convenient. It's a convenience store. That's why I said like and subscribe. Solve the square root of v minus 4 equals 3. If you're trying to solve an equation where your variable is stuck inside a square root, this is what you need to do. You need to make sure that the square root is all alone on one side. Well, happy day. It is. Now, how do I get rid of a square root? Well, you square it. And if I square the left side, well, guess what? I have to square the right side too. The square and the square root cancel each other out, leaving us with just everything underneath. So v minus 4. 3 squared is 9. Solve this like a regular one-stepper. Add 4 to both sides. V is going to equal 13. Go in here, double check your work. 13 minus 4 is 9. The square root of 9 is 3. Hooray, we did it. And that's how it's done. Easy peasy. Solve the square root of 3n plus 12 equals the square root of n plus 8. If you have the square root of stuff equals the square root of stuff, it's very simple. Square both sides and get rid of the square roots. You're allowed to do that. Squares and square roots cancel each other out. So you're left with, on the left side, 3n plus 12, and on the right side, n plus 8. So those square roots, useless. Now what you're going to do is you're going to solve this guy like a regular old equation with variables on both sides of the equal sign. Subtract n from both sides, like so. 3n minus n is 2n. Drop down the plus 12, drop down the equals, drop down the 8. Now let's subtract 12 from both sides like we normally would. Okay, 2n equals negative 4. Divide both sides by 2 to round this problem out. Negative 4 divided by 2 is negative 2. Now, it may not be the worst idea to go up here and check your work by plugging it in. 3 times negative 6, or negative 2 is negative 6. Negative 6 plus 12 would give me 6, square root of 6. That's going to equal the square root of negative 2 plus 8, which is 6. They do match up. You did it right. All is well. So the answer is n equals negative 2. You always really want to check your work with square roots because you're not allowed to take the square root of a negative number. At least not until Algebra 2. Watch those videos. You'll get there. Solve 90 equals 9 times the square root of 25v. First things first, square root of 25. Well, hold on. The square root of 25 is just 5. So let's do that and get that out of the way, leaving square root of v all alone by itself. So 90 is going to equal 9 times 5, which is 45 times the square root of v. Now, in order to solve an equation where a variable is trapped inside the square root, is we want to get rid of everything and leave the square root all alone by itself. So let's divide both sides by 45, divide both sides by 45, cross u out. That leaves me with 90 over 45, which is 2, equals the square root of v. Now, I need to get rid of that square root. How do you get rid of a square root? Well, you square it. And if I square the right side, guess what? Square the left side too. 2 squared is 4. 4 equals the square root of v squared. The square root and the squared cancel each other out, leaving you with v. So v is going to equal 4. And if you want to, you can go in here and check your work and say, all right, well, let's go up here and let's pretend that v is 4. So if v is 4, I have 25 times 4, and the square root of 25 times 4 is the square root of 100. The square root of 100 is 10. So at the end of the day, after you check everything, you find out that v does equal 4, all is well, everybody's happy, everybody wins. Thanks for watching, like and subscribe.